These are the notes for AP Calculus on the topic of polar equations. So with polar equations, each point in the plane can be assigned polar coordinates, r and theta, where r is the distance from the origin to the point, and theta is the directed angle to point P, measured in radians. So rather than your traditional coordinates, x and y coordinates, we use r and theta for the radius and the angle. So an easy way to see how these coordinates relate is by looking at this triangle right here. So if this is our point right here, if we had x and y coordinates, x would represent the horizontal distance from here to here of the triangle. You can see this is the right triangle here. And y would represent the vertical distance from the x-axis to this point. That would be the y coordinate. And in polar coordinates, rather than using x and y, the way we get to this point is by using the angle theta here in radians, and the radius, how far it is from the origin to that point, to get to the same place. So using our triangle, we can relate that in different ways. To get the angle in there, you can see you could take, if you wanted to get this coordinate in there, you can see based on this angle, this is the adjacent and this is the hypotenuse. So the trig function that uses the adjacent and the hypotenuse is cosine. So you could say cosine of theta equals the adjacent, which is x, divided by the hypotenuse, which is r, the radius, to get a relationship between the x coordinate and the radius and theta. And to simplify that, to get rid of the fraction there, you can just multiply both sides of the equation by r. So then the r is to reduce out there, you can get x equals r cosine theta. So that's where that equation right there comes from. Similar fashion, to relate, to get y in, the y coordinate in there, you can use, we'll notice theta is right here, so the y represents the opposite side, and r is the hypotenuse. So you could say the sine of theta equals the opposite, which is y, over the hypotenuse, which is r. And again, to simplify that equation, get rid of the fraction, you can just multiply both sides of the equation by r. Again, the r's are going to reduce out there, r divided by r is 1. And that's going to lead you to this equation, y equals r times the sine of theta. And those are the two most frequently used equations we'll use when trying to go from polar to traditional Cartesian coordinates using x and y. Other equations you can see using this triangle, you could also use the Pythagorean theorem and get the sum of the legs squared, x squared plus y squared equals the hypotenuse squared. That's where this one comes from the Pythagorean theorem. You could also use tangent and say the tangent of theta equals the opposite over the adjacent, y over x. And again, the two we'll use most frequently are these first two. So this says, given the polar curve r equals 1, 2 minus 2 times the sine of theta, where theta is between 0 and pi, write expressions for x and y in terms of theta. Okay. So to get the x coordinate in there, we'll use this equation, x equals r times the cosine of theta. And we want it just in terms of theta, which means we don't want the r in there. The way we get the r out of there is by substitution. We know the radius, r, is 1 minus 2 times the sine of theta, so we can substitute that in directly right there. So that would be 1 minus 2 sine of theta times the cosine of theta. So now this is actually in terms of theta, because there's no more, that's the x, there's no more r in there. Theta is the only variable in the equation for x. So now if we know what theta was, we can figure out what the x coordinate is. And if you want to simplify that, you could distribute out the cosine. So you could write x equals 1 times cosine theta is cosine theta minus 2 sine theta times cosine theta. So either way is correct. This one might be a little simpler to work with depending on what you're trying to do. Now, that's the x coordinate in terms of theta. Now let's get the y coordinate in terms of theta. So to get the y coordinate in there, you would start with this equation, y equals r sine of theta. And these are ones you just want, I mean, you can draw the triangle if you forget, but it's faster if you just memorize these equations. So again, we want it in terms of theta, but there's that r in there. So again, we can substitute this, what r equals on our particular curve, 1 minus 2 sine of theta in for r. Then dy equals 1 minus 2 times the sine of theta times the sine of theta. Again, you could leave it like that. Now it is in terms of theta. There's no more r in there, or you could distribute it out. If you distribute out the sine theta, that would give you y equals 1 times sine theta is sine theta. Minus 2, well, sine theta times sine theta is sine theta squared. You could write the squared right there, but it's actually easier to see, to work with, if you put parentheses squared. And that's really what's happening there. We've got sine theta times another sine theta. So now, if we knew what theta was, we could figure out what the x-coordinate is and what the y-coordinate is to put it back in traditional Cartesian coordinates. Now let's look at the same equation here. And let's complete the table and use it to sketch the graph for this polar curve. So notice it's just between 0 and pi. And so what we're going to do is plug these simple angles in here one at a time and try to figure out what this curve looks like here. So let's go ahead and substitute in some simple values. We can evaluate without a calculator and substitute in for theta to figure out what r is to help us graph this. So if we substitute in 0, then r would be 1 minus 2 times the sine of 0. And the sine of 0, well, 0 is right there. And the sine is the y-coordinate, so that's 0. So that's 1 minus 2 times 0 gives you 1. So the way you graph it with polar coordinates, you use the angle to tell which direction to go, and the radius to tell how far to go in that direction. So when we graph it, the direction 0 is this direction on the circle, that's our angle, and 1 is the radius, so we go 1 in that direction, that gives us our first point on the graph. Now let's try pi over 6. So it'd be 1 minus 2 times the sine of pi over 6. So pi over 6 is like 30 degrees, it's right here. Sine is the opposite of hypotenuse, so the opposite would be 1, hypotenuse would be 2, so it'd be 1/2. The sine of pi over 6 would be 1 minus 2 times 1/2. Well, that'd be 1 minus 2 times 1/2 is just 1. Gives you 0. So what that tells us in the pi over 6 direction, you can see this one is, since this is 90 degrees here, it's divided into thirds. So this is pi over 6 right here. Because it's 2 pi over 6 or pi over 3 right there. So pi over 6, well, if the radius is 0, that means we don't go anywhere from the origin. It just stays right at the origin right there. Now let's try pi over 4. So 1 minus 2 times the sine of pi over 4. Well, pi over 4 is like 45 degrees. It's right here. Sine is the opposite over hypotenuse. So 1 over root 2, which simplifies to be root 2 over 2. So the 2's reduce out again, and we get 1 minus the square root of 2. Here we have to just do a little approximation here. So this is approximately equal to 1 minus, square root of 2 is between 1 and 2, because square root of 1 is 1, square root of 4 is 2, and it's closer to 1, so it's less than 1.5, so let's estimate around 1.3. So that's roughly negative 0.3. Now, when the radius is negative, what that means is you actually go in the opposite direction of the angle. So pi over 4, let's see, this would be 90 degrees here. Pi over 4 would be right there. We don't have a line drawn there, but pi over 4 would be that direction. But the radius is negative 0.3. So instead of going the pi over 4 direction, we go the opposite direction this way. And about negative 0.3, well, 0.5 would be halfway to 1, which is right here. So 0.3 would be about right there. Now let's try pi over 3. So it'd be 1 minus 2 times the sine of pi over 3. It'd be 1 minus 2 times, well, pi over 3 is like 60 degrees. So that's root 3, and that's 2. So it'd be root 3 over 2. That'd be a 1 minus, again, the 2's reduce out. So 1 minus root 3. So approximately 1 minus, again, square root of 3, just like square root of 2, is between 1 and 2. The square root of 1 is 1, square root of 4 is 2. But this time, 3 is closer to 4, so that's going to be closer to 2. So this is around, we can estimate like around 1.7, 1.8. So that would be negative 0.7. So now when we graph it, pi over 3 would be 60 degrees, so it would be like right here. This whole thing is 90 degrees. Or you can, this is pi over 6, 2 pi over 6, 3 pi over 6. So either way, it's right here. But we have a negative angle again, so negative 0.7. Well, this would be negative 1. We go the opposite direction from there. The negative 0.7 is about right there, approximately. Now let's try pi over 2. We do 1 minus 2 sine of pi over 2. Pi over 2 is right here. Sine is a y-coordinate, so that's 1. So that's 1 minus 2 gives you negative 1. So pi over 2, which is up on the unit circle in that direction, again, the radius is negative, so we go the opposite way. We go right down here. This is the point right there. Now let's keep going all the way to pi here using the simpler angles here. So 2 pi over 3. Sine of 2 pi over 3. Well, 2 pi over 3 is over here. Sine is 3 over 2, just like pi over 3 here. Both are positive there. So it's root 3 over 2. So you can see that's the same as what we got for pi over 3. So that's again going to be approximately negative 0.7 again. So 2 pi over 3 is right here. And this would be pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, which reduces to 2 pi over 3. So we go the opposite way, negative 1 right there. Now let's try 3 pi over 4. So 1 minus 2 times the sine of 3 pi over 4. Well, sine of 3 pi over 4 is right here. It's going to be a 1 over root 2, same as root 2 over 2. Notice we had that one before we did pi over 4, so that's going to be approximately negative 0.3. So in the 3 pi over 4, this is pi over 4 will be right here, pi over 2, 3 pi over 4 will be right here, the 45 degree angle from the x-axis. So again, we go the opposite direction, about pi over negative 0.3, so around right there. And then let's take a look at 5 pi over 6. 1 minus 2 times the sine. 5 pi over 6. Well, sine of 5 pi over 6. 5 pi over 6 over here. Again, that'd be 1 over 2, 1/2. We got that one already. That's the 2 to reduce out, we get 1 minus 1, we get 0. So 5 pi over 6 would normally be this angle here, but we do a 0, so we end up right here. And finally, pi. We plug in pi, 1 minus 2 times the sine of pi. Well, pi is right here, and the sine is the y-coordinate, so that's 0. So it'd be 1 minus 2 times 0, gives you 1 minus 0, which is 1. So in the pi direction, we end up at 1 right here. So, to see what the curve looks like, remember we passed through this twice on the second point and the second to last point. So you can see we're not going to have just a straight line, there's going to be a curve here. So the curve down like this, the most logical way, it's probably that we don't know exactly how it looks, but something like this, curves down like that. Oops, this was supposed to be 0.7, sorry about that. I don't know why I went all the way to -1, so that point should be not as far as I drew it there. Remember that was the angle 2 pi over 3, which was negative 0.7, so I drew that all the way to -1, sorry about that. There we go. Like this, and then over hit this point again, and then it's over to this point. Okay, so there's a rough sketch of our graph from 0 to pi. All right. Let's take a look at one more of these. This one we've got r equals 2 cosine of theta squared. So, again, this one's from 0 to 2 pi, so we want expressions for x and y in terms of theta. So again, let's start with x equals r cosine theta. And again, we want it in terms of theta, so to get the theta out, to get the r out of there, we can substitute this in there. R right there. So we have x equals 2. Now when that squared is there, what it really means is this, cosine theta squared, and then times another cosine of theta. So you can simplify this and make it x equals 2 cosine of theta cubed. So now there's an expression for x in terms of theta. Now to get the y-coordinate in there, we'll use again the equation y equals r sine of theta. And then to get the r out of there, we plug in our specific r for this curve, which is 2 cosine of theta squared. And then times sine theta. This time there's really nothing to simplify there. So there's your y-coordinate in terms of theta. Again, later on in the year we'll use these equations to do other things, but for now we're just getting used to getting the x and y coordinate in terms of theta. Now let's look at the graph of this curve. So to sketch the graph of this curve, yeah, let's substitute in some specific values here to graph this. And I'm just going to move the graph over here so we can see it a little better. Okay, so let's go ahead and substitute in 0 for theta. So remember, this is the same. This time we're going from 0 to 2 pi. R equals 2 cosine theta. That squared really means the cosine is being squared. So let's plug in 0. So that'd be 2 cosine of 0. Oops. Cosine of 0 squared. Well, cosine of 0. Cosine is the angle of 0. Cosine is the x coordinate, so that's 1. So that's 2 times 1 squared. 1 squared is 1. 2 times 1 gives you 2. So that tells us on our graph, in the direction 0, the radius is 2. Here's 1, 2. So right there. Now let's try pi over 4. So 2 times the cosine, pi over 4 squared. Well, pi over 4, 45 degree angles right here. Whoops. Cosine is the adjacent over hypotenuse. So 1 over root 2. You could simplify it to be root 2 over 2, but here it's not really necessary to do that because it's getting squared. So you could, but it's not really necessary. Either way, you get the same answer. So if you square that first, you get 2. 1 squared is just 1. Square root of 2 squared is 2. Let's see, the 2's reduced out, leaving you with just 1. So in the pi over 4 direction, right here, 45-degree angles, the radius is 1. So right there. Now let's try pi over 2. Pi over 2 cosine, again, is the x coordinate. What an x coordinate of pi over 2 is 0, so that's 2 times 0 squared gives you 2 times 0, which is 0. So in the pi over 2 direction, normally that would be up, but the radius is 0, so we don't go anywhere, we stay right there. Now let's try 3 pi over 4. Cosine of 3 pi over 4. Be negative 1 over root 2, or if you simplify it, negative root 2 over 2, either way. When you square that, you get 2. Negative 1 squared is 1, square root of 2 squared is 2, so the 2 is reduced out, so you get 1. So in the 3 pi over 4 direction, here we get 1. Then pi, 2 cosine of pi squared at pi, right here. Cosine again is the x coordinate, which is negative 1. That's 2 times negative 1 squared, do 2 times 1, which is 2. So in the pi direction, just this way, the radius is 2, so right there. Now let's try 5 pi over 4. Cosine of 5 pi over 4. Right down there, 45-degree angle, negative 1 over root 2. Notice we get the same thing here. Oops. When we did 3 pi over 4, so that's going to still be 2 times 1/2, which is 1. So 5 pi over 4 be 1. Up there. 3 pi over 2. Cosine of 3 pi over 2. And it's the x coordinate, which is 0. So that's 2 times 0 squared would be 0. So again, in the 3 pi over 2 direction, normally we'd head this way, but it's just at 0 right there. And then 7 pi over 4. Pi over 4 would be this direction. Cosine of 7 pi over 4 be 1 over root 2. Squared, again, is 2 times 1 squared is 1, square root of 2 squared is 2, so again you get 1. 7 pi over 4 in this direction, we go 1 in origin. And finally 2 pi, we kind of already did this one, because 2 pi is in the exact same place as 0 right here. So cosine again is 1. Get 2 times 1 gives you 2. So it ends up backwards. So we can do a rough sketch based on the points we found. So back here, you can see it goes like this, back to here, to there, there, there. All right, now let's take a look at some different types of problems there. This time we're actually given the graphs of two curves. You can see r equals 2 sine squared of 2 theta plus 1 and r equals 2 from 0 to pi. And we want to find all the angles, theta, where the graphs intersect and label them on the graph. So you can see the places where these graphs intersect. Well, first to see which is which, let's start with r equals 2. Well, if the radius is always 2 no matter what the angle is, let's see, that would form this curve right here, right? That would just really be a circle if we were going all the way from 0 to pi. That's just a semicircle because we're just going from 0 to pi. And that must mean the other one, looks like rabbit ears here, that must be this curve, the 2 sine 2 theta squared plus 1. So what we're looking for is all the angles where these two graphs intersect. In this case, there's 4 different angles. So let's see how we go about finding it. Well, at those 2 places, notice what's true is the radius from there in polar coordinates is identical, right? And so is the angle, which is what we're looking for. So if we know the radius is equal, and this is what r equals, and this is what r equals, shouldn't we be able to set these equal to each other to solve for what theta would have to make the radius is equal? So let's apply that and say, okay, so we have 2 sine of 2 theta, and again, whatever that squared is, it really means this whole sine of 2 theta is squared, and plus 1 equals 2. And this radius here. So first thing you want to do is isolate the trig function. Let's subtract the 1. Gives you 2 sine of 2 theta squared equals 1. And then divide by 2. So we get, oops, I forgot the parentheses here. So we get sine of 2 theta squared equals 1/2. And then to get rid of the squared, take the square root of both sides. Gives you the sine of 2 theta. Square root of 1 is 1. Square root of 2, we write as root 2. However, whenever you take an even root of both sides, it's the square root in this case. Remember, you need the plus or minus. So it could be positive or negative 1 over root 2. And then what we want to do is find the angles where that happens. Notice, even though this says 0 to pi, notice we've got 2 theta in there. So if you multiply these all by 2, 0 times 2 is still 0. 2 times theta is 2 theta. Sorry, whoops, I said 2 theta, but I wrote 2 pi. 2 theta. And 2 times pi is 2 pi. So, because there's a 2 theta in there instead of just theta, 2 theta is actually between 0 and 2 pi when theta is between 0 and pi. So that's where we're looking, between 0 and 2 pi, where sine is 1 over root 2. So let's draw that. Well, since it's plus or minus, it could be in all 4 quadrants. Could be right here. Where it's positive 1 root 2. That's pi over 4. Could be right here. Well, again, it's positive 1 over root 2. That's 3 pi over 4. Okay, so let's start writing this down. And what we're going to set equal to that is not theta, but 2 theta, because that's what's inside the trig function. If 2 theta equals pi over 4, then sine of pi over 4 would equal positive 1 over 2. So 2 theta could equal pi over 4. 2 theta could equal 3 pi over 4. But remember, it's plus or minus, so it could be also in these quadrants where sine is negative. Negative 1 over root 2. 3 pi over 4, this is pi, which is 4 pi over 4. So this would be 5 pi over 4. So 2 theta could equal 5 pi over 4. And finally, in the 4th quadrant here, negative 1 over root 2. This is 8 pi. Sorry, this is 2 pi, which is 8 pi over 4. So this would be pi over 4 less than 7 pi over 4. The 6 pi over 4 is right here because that reduces to 3 pi over 2. So 2 theta could equal 7 pi over 4. The last step to solve for theta, divide by 2. But when you divide by 2, that's really like multiplying by a half. So you don't have to divide by numbers like multiplying by its reciprocal. So that makes it easier to see that theta would equal pi over 8. Let's see, pi over 8 on here would correspond to this point of intersection right here. Because that's even less than pi over 6, right? Which is a little bit more than that. So pi over 8 would be right there. Here, if you divide by 2, that becomes 3 pi over 8. You can see that's less than 4 pi over 8, which is a pi over 2. So that would correspond to this one right here, 3 pi over 8. Divide this one by 2, multiply by half. Theta would equal 5 pi over 8. That's a little more than pi over 2, which would be 4 pi over 8. So that would be 5 pi over 8 would be right here. And divide this by 2, theta would equal 7 pi over 8. You can see it's a little less than pi, which would be 8 pi over 8, so this one corresponds to 7 pi over 8. And for now, that's all we're doing, but again, we'll use this later on in the year, build upon this, do some other things with these polar graphs. But first key is figuring out where they intersect. All right, let's take a look at one more of these. Here we've got, again, a more complicated one, 2 cosine of 5 theta plus 3 equals r equals 2. Again, you can see r equals, let's see, this one should be r equals 4 actually, sorry about that.